Welcome to Unstuck. Today, group anagrams take a list of words and bucket the ones made of the same letters. The trick that solves it, the canonical key, is one of the most reusable ideas in programming. From scratch in Rust, beginner friendly. Given it tanat bat, the group anagrams, it teat together, tanat together, bat alone. The naive way compares everything with everything. The smart way needs one insight. This one builds directly on our valid anagram episode, link in the description. A like really helps. Let's start naive. The obvious approach. Take each word and compare it against the representative of every group you've made so far. If it's an anagram of one, join that group. Otherwise, start a new one. It works, but every word scans every group, so the comparisons grow with n squared. Here it is. For each word, loop over the groups, sort both words letters, compare. Notice we resort the same representative over and over, wasted work stacked on top of the n squared scan. On this small list, it gets the right groups, but on 6,000 words, 150 milliseconds of pairwise scanning. Let's find the insight that kills all of it. Here's the insight. Sort the letters of it, you get a 80, sort add a 8 again. Every anagram collapses to the exact same sorted string. That sorted form is a canonical key, a single fingerprint shared by the whole family. So instead of comparing words to each other, we just file each word under its fingerprint. The whole solution is now 4 lines. Sort the words bytes to make the key and push the word into a hash map entry under the key. Entry or default creates the bucket the first time and reuses it after. No group ever compares against another. Same groups on the small list and the 6,000 words drop from 150 milliseconds to 1. 150 times faster because each word does one hash lookup instead of scanning every group. The complexity. Pairwise wasn't squared in the number of words. With the key, each word costs one sort of its own letters. Put K for a code letter word or plus one hash insert. Linear in the number of words, same 770 groups, 150 times faster. Should to trace it. It sorts to itash, new bucket. T sorts to ita, same bucket, join it. Tan sorts to anata, new bucket. Ata, it again, third member. The map builds the groups all by itself. One refinement. Instead of sorting, you can use the letter count array from our valid anagram episode as the key. 26 counts, no sorting at all. Same principle, slightly faster. The idea that matters is the canonical fingerprint, not which fingerprint you pick. And the lesson travels far beyond anagrams. Whenever you need to group similar things, look for a canonical form and hash byte. Deduplication, clustering, cache keys, normalizing user input, it's the same move every time. Common mistakes: reaching for pairwise comparison when a key exists, resorting the same words over and over like our naive version did, and mixing up string and byte keys. Either works, just stay consistent. Recap: all anagrams share the same sorted letters, so use that as a hash map key and group everything in a single pass. One insight 150 times faster, that's group anagrams. Quick one, if these help you, the wallet's on screen and there's a Ko-fi link in the description. Every tip funds the next one. The full Rust code is in the description. If this helped, hit like and subscribe. A new coding challenge every day. See you in the next one.